Hello, everyone.
Carlos.
How are all my favorite scientists? Y'all doing well?
For several days, and his apartment was right by a courthouse. So
All right.
he was his best friend, and she told him to
Let's
learn the
see,
native
trying to
language.
figure out here who's. There we go.
Spanish.
All right. Anybody have any questions for me before we get started today? Isaac.
Well, just a fun thing that I'm doing, but I'm making an escape room for my parents in my house.
Sorry, you're gonna have to talk a little bit louder.
I'm making an escape room.
Are you really?
Uh-huh.
Well, that's fun.
For my birthday party, my dad got a bunch of locks for the escape room, and I'm just like randomly doing one.
Wow, that's really fun. That is an exciting way to have a birthday party. Yeah, anybody else? Maisie.
For my art class, I have to color like the doodle designs that I did.
Doodle designs?
Yeah,
On what? What'd you do them on?
paper.
Oh, that's cool.
Yeah.
Very cool. All right. All right, let's go ahead and get started. All right, so you guys are right in the middle of learning about volcanoes. I'm going to do a little bit of a review about volcanoes. And of course, remember the difference between a natural hazard and a natural disaster. A hazard is something that could be a potential to harm someone, where a disaster is something that is damaging, that is causing trouble for humans. All right, so a couple of jokes for you here. Volcanoes are so rude because they interrupt a lot. What did the volcano say to the earth? If you don't stop pressuring me, I'm going to explode. How about this one? How does a volcano greet a snowman? Nice to melt you. Look at that. I can't believe that picture. All right. What did one volcano say to the other? I lava you. All right. All right. So what do we mean by volcano? What is a volcano anyway? Come on, somebody knows what a volcano is. Let's see here. You like that one with the snowman? Yeah. Yeah. Valley, can you hear now? Okay, good. Good. Maisie.
Volcanoes, I would say that they're mountains, but they have lava in them.
Good. That's as good a definition as I've heard. Yeah, that's a great one. So here's our official definition. It's an opening on the surface of a planet like Earth or a moon that allows material that's warmer than its surroundings to escape. When that material escapes, it causes an eruption. And over time, a mountain forms, and it allows, of course, that magma to come out. So an eruption can be explosive, like the one in the picture there, sending material high into the sky, or it can just be calmer with gentle flows of material down. Now, there's 3 kinds of volcanoes. There's a lot of kinds, but there's 3 main kinds. Anybody remember what those 3 main kinds of volcanoes are? Henry.
Cinder cone.
Yep.
I keep thinking of the explosion. Cinder cone. That's all I can think of right now.
Okay. Maisie?
Geyser.
A geyser is water coming up out of the ground. Meredith?
There's a cinder cone and a shield cone and one other that I forgot, but
Aisha?
composite.
Very good. So we got composite, shield, and cinder cone. There they all are right there. Now let's look at each of those. So a cinder cone volcano, it's one that has a single vent right here in the middle. It doesn't have those little vents that come out the side. One vent right in the middle there. And it forms small mountains or hills that have steep sides. I'm going to ask you guys all to keep your cameras, your microphones muted because I'm hearing a lot of background noise. That would be helpful. Yeah, Drake, I like the shield there. That's pretty cool. So here is a video that shows you a cinder cone volcano in Lassen National Park, California.
So I'm about to climb a cinder cone volcano. That one. So it's really steep. So cinder cone volcanoes, as we know, are really steep. So right now I'm in Northern California. So it's sitting right on a subduction zone called the Ring of Fire. So it's a subduction zone all around the Pacific Ocean. So subduction zones create cinder cone volcanoes typically because they're explosive. When you have a subduction zone, it creates an explosive volcano like this cinder cone volcano. Cinder cone volcanoes, one thing, they're steep. Second, they're explosive, and they produce tons of these cinders. So what looks like sand that I'm walking on is actually a whole bunch of volcanic cinders. Makes this trail really a pain to climb, but it's so pretty. So one of the things we talk about cinder cone volcanoes, they're really steep. So climbing this cinder cone volcano is really a bear. This is like, I mean, I'm having fun, but this is a really steep climb. So it's gonna be like this all the way up. Cinder cone volcano.
So when he gets away from the camera, it makes it a little bit harder to hear. So most of you can hear that. Let's try turning your speakers up if some of them are a little bit lower. So Drake, you've been there? Did you climb a cinder cone volcano there? You tried to? Yeah, they're not easy. It's like walking up a hill of sand. That's pretty amazing. I think that would be kind of tough to climb. Maisie.
Me and my family went to Hawaii and we went to like I think this tour and we saw like lots of volcano rocks.
Yeah, you will find them because Hawaii, of course, is the islands were made with volcanoes. Those are hot spots in the middle there. Yeah, very cool. All right, so that was a cinder cone. Cinder cone, I think, is what we think of when we think of a volcano, like one vent in the middle, lava coming out the top, cinder being shot out of the top. But there are also composite volcanoes, and look at the vents. There's many of them. These form large and tall mountains. So see the layers that we have here? So that's how they form. So watch this animation to see how the composite volcano forms. So more and more, it lays down more and more lava, making more layers. So the word composite basically means a collection of multiple things. So this would be a collection of multiple layers on that composite. And then the third kind is the shield volcano. This has fast flowing lava and it forms short, wide mountains. Looks kind of like a shield laying on the ground. That's why it's called a shield volcano. So these mountains are wide, but they're not very tall. So here you can see all three of them together. Cinder cone volcanoes have that single vent right in the middle and cinders all over. The composite volcanoes have multiple vents off the side there, large, tall mountains, and then the shield ones, fast flowing lava with short, wide mountains. Which type is the most destructive? I don't think there's a difference. I think it's all like, I don't think one is more destructive than another. I don't know for sure the answer to that though. That's a really good question and I'm going to look it up. So give me 1 second here. All right, which kind of volcano is the most destructive? Let's see here. The most destructive kind of volcano is the composite. There is a difference. All right, here's why. these composite volcanoes often, so that'd be this kind here, right here. They often produce highly explosive eruptions because the magma is very viscous. So remember, that means thick, more syrupy. It also traps gases, leading to a buildup in pressure that releases in a powerful blast. And it creates fast-moving currents of hot gas, ash, and volcanic matter. They're also prone to dangerous volcanic mud flows. Ooh, so when volcanic ash mixes with water, it forms a fast-moving slurry that can bury communities and infrastructures. So you guys have heard of Mount St. Helens? That was the last big one that erupted in the continental United States. That was a composite volcano. Yeah, that was a good question, Valerie. Thanks for asking that. If you survive the lava, you can die from it. Yeah, you can die from ash in the air, from gases that are in the air. Absolutely. All right. One interesting thing is that you could also have volcanoes underwater. So magma reaches the ocean floor through cracks in the crust that lie over the ocean. And the magma real quickly solidifies once it hits the water. So underwater volcanoes are constantly creating new ocean floor because as soon as that comes up and touches the cold water, it cools. All right, so we were talking about Hawaii. So you can see a hot spot. Hawaii is an example of a hot spot. So these are places within the mantle where the rocks melt to make magma. And they're another place with a lot of volcanic activity. They happen at the inside of the plate. So they're not along a plate boundary. So if we look right here, look where Hawaii is. It's right in the middle of that. This is the plate boundary here. This is the ring of fire. Hawaii's right in the middle. So these hot spots are in the middle, and they happen deep inside the earth, under it, within the mantle, where the magma pushes up and it rises to the surface, and it breaks through weak spots in the crust. I didn't think there were so many in Africa. Yeah. So you can see all of the hot spots that there are around the world there, and there are a lot in Africa. Yep. Now, when you have a hot spot, it's pretty easy for an island to occur. So new islands can form whenever a volcano erupts. Right here, you can see how this is happening. So the plate right here, the mantle, the lithosphere, if you will. Remember, lithosphere is the crust and the top part of the mantle, and that moves, and it's moving in this direction. So when the mantle, the lithosphere is over this crack, this hot spot, the mountain forms, and then it moves along and it forms another, and the island forms, and it forms another island, and then another. Yeah, Henry.
I think our book said that Hawaii is the tallest mountain if you measure from the ocean floor.
Yeah, from the ocean floor. Because you have to remember that when you've got a volcanic island that is created in the, in the ocean, a lot of it, in fact, the most of it is going to be underneath the surface of the water. Yeah, very cool. Here, this is a pretty cool ocean volcano video. This is a minute long. Let's watch this.
Scientists believe that 80% of the volcanic eruptions on Earth take place in the ocean. Most of these volcanoes are thousands of feet deep and difficult to find. But in May of 2009, scientists captured the deepest ocean eruption ever found. Nearly 4,000 feet below the surface of the Pacific Ocean, in an area between Samoa, Fiji, and Tonga, the West Mata volcano was discovered. The explosions of molten rock were spectacular. This volcano was producing Bonanite lavas, believed to be among the hottest erupting on Earth. Scientists also witnessed molten lava flowing across the deep ocean sea floor and spotted shrimp living near the volcano's most active areas. This research allows us to closely examine how ocean islands and undersea volcanoes are born. It may also shed light on how heat and matter transfer from the interior of the Earth to the surface, and how life adapts to some of the harshest conditions on our planet. Finding West Mata was a huge break for scientists, and for those interested in seeing what takes place in the deepest depths of our ocean.
Isn't that beautiful? And you could see as that lava was moving across the ocean floor, how quickly it was cooling and becoming rock. Can you survive lava? Well, once it's hardened and cooled, sure, you can walk on it. You can make houses on it. In fact, a lot of people do. But if it's hot, no. If lava poured over you, lava is molten. So it's very, very hot. All right, now let's look at Hawaii again here. You can kind of see it happening in this image right here. So this is a really famous example of the hot spot. So there's 8 major islands in the Hawaiian Islands, and each one is an active or an extinct volcano. So a hot spot lies underneath the biggest of them right now. It's called the Big Island in Hawaii. So the Big Island has an active volcano. Now, southeast of the Big Island, there's another new island that's already forming, and it has an active volcano that's caused by a hot spot. It's named Loihi. Is that, anybody speak Hawaiian and know if I got that right? Loihi. It's a seamount. Remember, a seamount is under the surface of the water. Scientists predict that it's going to continue getting bigger, and then it will become an island. It'll become the next island in this island chain. Yeah. Yeah. All right. So what sound do you think volcanoes make when they erupt? Think it's quiet, loud, gurgling, roaring? What do you think? What word would you use? A hiss and then a boom? Maisie?
I would say loud.
Loud, yeah. So let's listen to one.
What does a volcano sound like? Here's an example of an eruption in a housing area near the volcano Kilauea in Hawaii. The fountains of lava were at least 300 feet high. In this example, a fissure opened up on someone's driveway near Kilauea. Sound is a very important clue to what a volcano is doing. Lava and gas move around under the ground and make noise. Those sounds are much too low for humans to hear, but scientists use special instruments to record those sounds and earthquakes. And by studying those recordings, scientists can get an idea of what may be going on deep inside the volcano. And that may help them forecast future eruptions and save lives.
Where's your roar? Isaac, don't draw on the screen, please. All right, so can a volcano make an earthquake? So volcanoes and earthquakes are 2 different kinds of natural hazards. Remember that they're all going to be caused by movements underneath. An earthquake happens when you've got pressure built up along usually the edge of a plate or a fault, and it lets go. But where the plates are, that's often where volcanoes are too. So they can happen at the same time, but one doesn't necessarily create the other. All right, so that roaring sound that we heard, that by an eruptive volcano, that happens because of friction caused by those hot gases coming up through the vents that are in the ground. So volcanoes produce sounds that you can hear, like the ones that we listen to, but it also produces ones that you can't hear. And the ones that you can't hear are usually much more powerful than the ones that you can. We call that infrasound. And that's one type of data that can indicate that a volcano is getting more active if the infrasound increases. New islands will be created forever if Hawaii keeps moving. Yes, absolutely, it will. What if there's an earthquake in a volcano? Well, I mean, if an earthquake is a sudden forceful movement of the earth, then that kind of is what's happening in a volcano, but it's a different phenomenon. It's a different phenomenon, yeah. All right, so scientists don't just listen to the sounds that they hear when the volcano is erupting. They're interested in the sound before the eruption happens because that can give them an idea of what's going on. So the higher up in the volcano's chamber the magma is, so higher up at the top, the more high pitched that sound is going to be. The lower it is in the chamber, the more low pitched it's going to be. And that difference in sound, that can tell the scientists how likely it is that that volcano will erupt soon, or whether even a volcano itself is becoming more active over time. Now, some of the sounds you can hear without any assistance, like you guys are hearing me now, but other sounds need to be heard with equipment. I don't know. So let's talk about the severity of volcanoes, or how severe they are. Let's watch this.
Scientists use different ways to measure natural events. The size of an earthquake is measured by its magnitude. Volcanic eruptions are measured on the Volcanic Explosivity Index. Scientists look at the amount of material ejected by the volcano, the height of the eruption column, and how long the eruption went on, and give it a number. The volcanic scale goes from 1 to 8, with each step increasing the size by a factor of 10. Mount St. Helens, the most destructive eruption in U.S. modern history, is only a number 5. The volcanic eruption that formed what is now the Yellowstone area is considered to be an 8. Luckily, we haven't had another volcanic eruption at the 8 level for the past 10,000 years.
So here's what the Volcanic Explosivity Index looks like. Scientists use this to determine how severe an eruption was. And no, Maisie, we cannot stop a volcanic eruption. Once it starts, just have to wait it out. So this VEI, or Volcanic Explosivity Index, it measures how much material is brought up and deposited on the surface and into the atmosphere during an eruption. So, those are things that they measure right here. And you can see that the higher up the number goes, they're increasing by a factor of 10 every time, just like we saw with the scales that we measure earthquakes with too. So take a look here at this where it says frequency. That means how often it happens. So really some of these low volcanic explosivity indexes, the ones that are low numbers, they happen daily. These mega colossal ones happen only about every 10,000 years. So the low ones happen more often. The more explosive ones are pretty rare. So scientists think that one of these that's an 8, is going to happen, not happen every, but every 10,000 years. Now, a volcano that has erupted at least once in the last 10,000 years is considered active. So an active volcano is one that scientists think is likely to erupt again. There's more than 1,500 of them on the Earth that scientists think could erupt again. That's a lot, 1,500. But of course, a dormant one is one that hasn't erupted in the last 10,000 years, but might again sometime, like the Yellowstone National Park one. There's a very large volcano there that erupted about 600,000 years ago. The scientists think that it will erupt again in the future. Now, extinct means extinct. We're not, just like we don't think dinosaurs are coming back, an extinct volcano is not expected to erupt again at any point in the future.
Dr. J.
Yes. Oh, I'm sorry, Isaac. See, Isaac, there's an example. I want you to, can you see your little hand up in the corner? It's so light because it's against that light background. So that was good that you stopped me. So yes, thank you. Go ahead. Can't hear you.
This better?
Yes.
How about this?
Go ahead. Just ask your question.
Okay, so I forgot one of them, but so you know how like water usually take out fire, right?
Yep.
But with magma lava, what amount of water is needed to like make the lava cool? Because if you have like a gallon of water and you put like super hot magma or lava in it, it's just gonna evaporate the water.
Right.
So how much water ratio to lava do you need, like?
That's a good question, and it has so many things that it depends on. It depends on what the lava is composed of. How hot is the lava? How much of it is there? Just like you could take an eyedropper, and if you put a little drop of water into the middle of a campfire, it's not going to do a thing. But if you dump a fire hose or a swimming pool worth of water on top of a campfire, it's going to burn it right out. So there isn't really any set number that you would say it takes this amount. Good question. Henry.
Can scientists predict like where they think a volcano will form in the future? Like there's not a volcano there yet, but they think there will be one there.
You can make some predictions, Henry. Like you can say that around the Ring of Fire, that's a place where two plates meet, we're more likely to see volcanoes form. I don't think there's any way to predict a hot spot that doesn't already exist. So like the one in the middle of the Hawaiian Islands, they're just going with what's already there. But you can predict that where there is one plate joining another, especially in an area that there have been volcanoes before, that there already are some, others might form in that area. They do a lot with sound. They listen with this really powerful equipment to what the sound is like, and they know what's happening with the magma underneath there to a certain degree. This is not an exact science. Yeah. A mini volcano in Mount St. Helens crater. Yeah. Yeah, it is.
It looks
Because
like
remember, once you have a volcanic eruption like Mount St. Helens, it's going to blow off the top, but that vent is still there. So it blows off the top. It makes that crater in the middle. Sometimes that crater fills up with water and it becomes a crater lake. Those are pretty cool. But the vent is still there. So the vent is going to continue putting out little bits of lava, little bits of ash. So there is going to be a little mini volcano in there. Yep. Yep. So how often a volcano erupts depends on a lot of different factors. Some of them just continuously erupt. They're just constantly putting out ash. Others of them have a lot of time in between, like Mount St. Helens is an example. Mount St. Helens, that's the picture on the right with the little mini volcano in it. It erupted in 1980. Before that, it hadn't erupted since 1857. So the one that's on the left there, that's Mount Fuji in Japan, and it erupted about 300 years ago. Yeah, right here is the little mini volcano that Isaac was talking about. Yep. All right, now, of course, volcanoes can cause a lot of damage, just like the earthquakes that we learned about. They can do a lot of trouble. Lava that comes out of volcanoes usually is pretty slow. Now, over time, it will destroy buildings. It will destroy things in its path, but usually because it's a slow process, people can just get out of the way. Like this is moving, but look where that guy's standing. He can easily run out of the way of that. Not always, though. Sometimes it happens fast. Sometimes lava flows can move quickly. Lava moving fast here. Now that house is on fire.
This is a perfect example of a lava flow. The heat,
that
I
guy?
would say it's what I'm feeling. I'm standing 20 feet away, about 130, 140 degrees Fahrenheit. And it's advancing to us. I think it's faster than a turtle can move, but less than a mile per hour. Notice what it's doing to the trees over here, just barreling its way through.
And there's no stopping that. And then, of course, sometimes lava can go really fast. Look at this one.
And take a look at this incredible video from the Big Island of Hawaii. That's
like a river.
Lava flow from Fissure 8. It is moving right next to the Leilani Estates community and down to the ocean.
Pretty fast. And of course, gas and ash can travel quickly, and they're hot and they're poisonous. So the volcano can release lots of gas before it erupts, and then while it's erupting, and then it can continue releasing gas and ash even after the lava has erupted. Now, gas travels fast, and the gases will kill most organisms that they come into contact with. So hot gas and ash can cover and destroy an entire town, an entire city, and it can result in the death of a whole population of people. So it can block traffic. It can even block the sun's rays and make it so that photosynthesis can't happen in those areas because the sun is blocked out. Ballet.
What about underwater volcanoes? How does gas work there? And does it
So the
affect?
gas, yeah, it's a good
Sorry.
question. The gas, some of the gas is going to dissolve into the water. Some of it is going to make its way up to the surface and be released onto the surface. I would say most of it is going to just dissolve into the water and be spread out. Let me see here. If it is slow enough, not as hot, could a house hose cool it off? It really depends. Probably not, but it depends on how much there is. Imagine sleeping in that house. Depends on how hot. Yeah, all depends on how hot the lava is. Yeah, excellent. So a major eruption can happen along an earthquake, along with it. They can happen at the same time. So remember that we talked about how earthquakes can trigger tsunamis. Well, so can volcanoes. Volcanoes can trigger tsunamis, and then tsunamis can hit distant shores as well. So predicting them. We know they can be dangerous. We know of examples of whole cities that have been wiped out because of volcanoes. Maisie.
What if the volcano was just full on gas?
Some are. Some volcanoes just release gas for a long period of time. And whether or not it's dangerous to people depends on the severity, depends on how much there is. If there's just a little gas that's coming out on a pretty continuous basis and it just floats off into the air, that's not going to be as dangerous as if there's a ton of gas that comes out and it sinks down to where the people are. Yeah. So we do know that these volcanoes can be pretty dangerous. So predicting them, that would be a really good thing, right? So being able to accurately predict them could save a lot of lives. So before you have a volcano erupt, you've got magma that's coming up to the surface. Now, sometimes that magma moving can cause movement of the earth. Those small earthquakes. Remember, when we say earthquake, what we mean is the movement of the lithosphere. Sometimes the magma moving, not the earthquake or the volcano, the movement of magma can cause those small earthquakes. So scientists look for small earthquakes that are anywhere near where a volcano is. And then a larger eruption often happens after the smaller ones do. So they check to see if there's any kind of volcanic change, a behavior change in the volcano. So a dormant volcano, one that hasn't erupted for a while but might someday, if it starts sending out gas or heat, that could be a sign of an eruption coming up. So we have an example in history you guys might have learned about a whole city that was buried by ash from a volcano. Anybody familiar with that? What's the name of that city? Yeah, Aisha, you got it, Pompeii. So this happened back in the year 79. Mount Vesuvius erupted violently. Scientists think it was a 5 on that VEI scale. Remember, the scale goes up to 8. Now, Pompeii, the city of Pompeii, was almost completely buried in ash, and it was completely lost to history for a long time until it was rediscovered. So the destruction and the burial was so complete, people of the time forgot that a city had ever been there. And the city was rediscovered and excavated hundreds of years later, and they found the remains of many people. So I've been to Pompeii, and one thing that really surprised me when I went there was how huge this city is. So this is what it looks like now. It's actually kind of crumbling because it's exposed to the elements now. So a lot of these buildings won't be there 100 years from now because they're kind of crumbling along. But yeah, did they have to drill through rock to rediscover it? I don't know if there was any rock. They were able to excavate it. Most of it would have been sand, that had over time covered it up.
The lava rock,
There wasn't a lot of lava with Mount Vesuvius in the Pompeii area. It was ash that killed the people. It was, you know, like feet and feet and feet of ash that covered it up. Now, some of that ash would have hardened over the years, but it wouldn't have become rock. It would have just become like a hardened kind of a crusty. Yeah, you guys ask good questions. So when scientists study past eruptions, could they find a fossil? What they found, Maisie, were the fossils of people, right? So they found that that's what a fossil is the remains or the imprint of a living thing in the layers, in the ash. Or so that, yeah, they found people, they found farm animals, they found pet animals. They did find a lot of fossils. So when scientists look for these past eruptions, when they study them, they look at things like how strong it was, what kind of gases, what kind of ash were released, and how fast the gases traveled. And they can a lot of times find that information by looking at sedimentary rock. Do you guys remember when we learned about sedimentary rock, we learned that it's layers. So if a layer will be put down and then compacted, another layer will be put down and then compacted. Well, if there's ash in that sedimentary rock from a volcano, then they know that there's a volcano that nearby that erupted at that time. They also look for any chemicals that would be found within the rocks. So when they are studying rocks near a volcano, they can tell things like the force of the eruption, where the gas and ash were released, and how quickly they traveled. That's pretty interesting, just from studying the sedimentary and igneous rock near a volcano. And of course, scientists use seismographs. We talked about that. A seismograph is the machine. Seismogram is the paper, the little chart that it puts out. So they use that to record the properties of earthquakes. Magma coming up can also cause this movement. It causes rocks that are in the crust to shift and to break. And then shifting rocks are experienced on the surface. So usually a volcanic eruption has major earthquakes at the same time and some minor ones that happen at the same time because of this movement of the earth. So the characteristics of earthquakes that are caused by that rising magma are a little bit different from earthquakes that are caused by plate motion. But scientists use these seismographs to be able to record both of them. Now, tilt meters are kind of cool. Magma that's coming up through the crust places a lot of force on the rocks that are around them. And some of that force can cause the ground to swell a little bit. Now, the swelling isn't something you could see. You wouldn't see movement of the rocks. You wouldn't see movement of the mountains or any equipment, but a tilt meter can tell. A tilt meter can notice it. It's this small piece of equipment. That's what we're looking at right here. A piece of equipment that's very sensitive to very small changes. So they'll place these tilt meters around volcanoes to check to see whether the ground is tilting or swelling or not. They were originally developed along with those seismographs, and they kind of work a little bit the same way, but they can let scientists know. Once again, if you can have any warning about any of these natural hazards, you can prevent them from becoming natural disasters. Maisie.
Are seismographs still like existed today?
Yep. Scientists use all this today. In addition to monitoring for ground movement, they also monitor the gases that are coming out of a volcano. Remember, magma under the ground is filled with gases, but those gases can't get out because there are rocks and magma trapping them. So when the magma comes up, it exposes those gases, and they then start to escape as well. So the gases will come out of a volcano before, during, and after an eruption. And the ones that come up before can be detected with gas sensors that scientists have. So they monitor the gas that's coming out of a volcano. When there's an increase, that might mean that magma is getting closer to the surface, and we might be looking at an eruption. So they also use what's called thermal imaging to detect hot magma because it warms the surrounding area. So things that are hot give off a kind of light that's called infrared light. You guys give off infrared light because you're warm. So we can't see infrared light, Guess what though? Mosquitoes can. That's kind of how they find you. They find you because you glow in the dark to them. Another thing that's kind of cool is that there's it's been recently shown that dogs give off or can see infrared light. So you know how when you get up from the couch, your dog sometimes goes and sits right where you were? That's because it can see the warm spot that you left behind. It can see the infrared warmth of the sofa where you were. So we can't see infrared light, but we've got cameras that can. So cooler objects don't give off much infrared, but warm objects do. So the hotter something is, the more infrared light it's going to give off. So looking at these objects with an infrared camera is what we call thermal imaging. So here's a couple pictures of thermal imaging. So as this is the guy with just looking at him normally, this is with thermal imaging. So you can see he's so covered up with warm clothes that he's not releasing much heat, but the magma behind him, or the lava, sorry, behind him is. So as magma comes up through the crust, the temperature of the ground near that volcano changes. The change might not be a lot. It might not even be something that you can detect, but when you look at it with this infrared camera, you might be able to see it. So thermal imaging is another way that we can know that magma is coming up close to the surface. There may be an eruption coming soon. Anybody know what GPS stands for? Valley.
I believe GPS stands for Global Positioning System.
You got it. It is Global Positioning System. So the Global Positioning System, this is a system that can be used to determine exactly where something is on the earth. We saw that a couple weeks ago when we saw the guy trying to find the pizza. So GPS relies on these satellites that were placed out into orbit in or around the earth, outside, up high in our atmosphere. So these satellites constantly put out signals. A GPS device that can get signals from 3 or 4 different satellites can tell where it is with a lot of accuracy. Now, rising magma puts a lot of force on rocks. Sometimes that causes the ground to shift and swell. GPS devices that are put around a volcano can detect those changes because the device moves when the ground shifts. So its position, according to the GPS, has changed as well. These shifts can also tell us that there is an upcoming volcanic eruption that is at least a possibility. And what do you guys think? Are there volcanoes elsewhere in our solar system? Do you think other planets have volcanoes on them? Yeah, you're right. You're right. There actually have been a lot of volcanoes on other planets in the past. And some places in our solar system have active volcanoes that are erupting right now. Venus and Earth are covered with extinct volcanoes. We even think that some of the moons of Jupiter and Saturn and Neptune have eruptions happening right now. And scientists have taken pictures of these from NASA spacecraft. So let's look at a couple of those. There's one there. So most people define the word volcano as an opening in the surface of the earth that lets molten rock, gas, ash escape. It lets all those things come out. Well, that definition works pretty well on Earth, but in our solar system, in other planets and moons that are in our solar system, there could be a big difference in the composition of gas or ash. So planets that are near the sun, those first 4 planets near the sun, those are rocky planets. And they are going to produce magma that's going to be, and then lava that's going to be similar to Earth's. But the ones that are out farther, the 4 planets that are out farther, those are called gas giants. And they have a lot of gas that would be making up the planet. So in that part of the solar system, we call the volcanoes cryovolcanoes. So instead of erupting molten hot rock, they erupt cold, liquid, or frozen gas, like ammonia and methane. So they're a little bit different in the way they erupt. This is a picture of Triton. Anybody know what Triton is a moon of? Which planet is Triton around? Drake.
Jupiter?
Nope, good guess though. Close.
Mars?
Nope, not Mars. Maisie?
I'm gonna guess the moon.
Nope. Isaac?
Neptune?
It's Neptune. Yeah, Triton is a moon of Neptune. Now, this was the very first place in our solar system where we found one of these cryovolcanoes. So the probe Voyager 2, it was called. I don't think we're going to have time, Meredith, but we'll see. We might. Voyager 2 saw plumes of nitrogen gas and dust 5 miles from the surface. So they were shooting this dust and nitrogen gas 5 miles up. And it's these eruptions that give Triton its smooth surface. Smooth, you say? Yeah, because everything that goes up falls back down to the surface, and it gives a really nice smooth blanket, similar to what snow looks like. You know how snow kind of smooths everything out? Well, this does the same thing. Yep. And this is Jupiter's moon, Io, and it has a volcano that has a plume 180 miles high. Look at that. So Io is the most volcanically active body in our whole solar system. This is Jupiter's, one of Jupiter's moons. And this surprises most people because it's really a long way from the sun. And it seems like it's pretty cold. But Io is a little tiny moon that has a lot of gravity from the giant Jupiter that's near it. So that gravity pulls on the moon, and it pulls on it so strongly that it actually deforms the shape of the moon. It's pretty cool. That deforming of the shape of the moon puts a lot of friction on the moon, and that makes it hot. And that gives it this hot volcanic activity. This one is Mars. This is, anybody know what the what moon this is off of Mars? What the name of it is? Maisie? I'm sorry. I said moon. I didn't mean to say moon. I meant to say volcano. What is a volcano on Mars?
I don't know.
This is called Olympus Mons, and it is the largest volcano in our solar system. It's as big around as the state of Arizona. So what kind of volcano do you think that is? You think that's a composite, a cinder cone, or a shield? What's it look like?
Shield.
Yeah, it looks like a shield. It is. It's formed because there are pulses of magma that come up, but there isn't any movement of tectonic plates on Mars. There's no plate tectonics there. So the magma keeps piling up in the same area. So we get this gentle lava that steadily builds up that shield volcano. This is a mountain this is actually a mountain of saltwater ice on the surface of a dwarf planet called Ceres. And it is thought to have been formed after a plume of saltwater and rock went up through the middle of the planet and then erupted into a plume of salty water. So not exactly lava, not exactly a volcano, but close, a mountain of salt water. All right, blue lava? There actually is blue lava. What do you guys think might happen to make lava blue? Why might there be blue lava? Maisie.
I'm gonna guess it gets really hot and the ocean connects.
Those are good guesses. Good guesses. I need you guys to keep, I'm going to have to turn off the chat in this class because you guys are not listening when I ask you to keep it to class talk. All right. So for next week, I'm going to have to turn it off. Sorry, I didn't want to have to do that, but I have to say it every week. So I'm going to have to turn it off. You'll be able to talk to me, but only me. All right, Valet.
Maybe a different chemical compound.
Yep, that's exactly what it is. It has sulfur in it, and sulfur gives an electric blue flame. So it looks like it's lava, but it isn't. It's called blue lava, but it isn't really lava. It's just burning sulfur that looks like lava. So there's a couple of these around the Earth. One place that you can see these blue fires is in Yellowstone National Park when there's a wildfire. So there's a lot of sulfur in Yellowstone National Park. And when there's a wildfire, it will burn that sulfur and it will give you that blue color. All right, let me see here what we're going to do. What do we have left? We just have a couple minutes left here. So I do want to show you guys this. 3 years ago, there was a major volcanic eruption in the Canary Islands off of Spain. Now, this began in September of 2021, and for 3 months, lava poured out. So you can see it made its way to the water. So it started here and it made its way down the terrain until it was in the water. It flowed to the sea, and while it was doing it, it engulfed 3,000 buildings. These are satellite pictures. Right there, you can see a satellite picture of La Palma, which is where it was. So the white right here that we're looking at, that's cloud cover. And right here, you can see the plume coming from the volcano. I want you guys to watch a video about that eruption.
Well, the wind direction's changed today because we're starting to see more ash falling in other places. This is La Laguna, a village that's just outside the restricted zone. These are the roadblocks where police are keeping people back from the villages that have been evacuated. And you can see how much ash has fallen here, and it's coming down the whole time. Sometimes really fine volcanic dust, sometimes thicker particles. If I hold out my hand, you might be able to actually see it falling from the sky and landing. And there's a risk that this side of the island actually gets cut off by the lava flow. That will probably happen at some point. So we're starting to see how everyday life is being disrupted here, and this eruption is causing problems not just for the people whose homes are directly at risk. And the big question is, how long will this last? And what will the future impact be? But for now, the emphasis is still on the volcano that continues to erupt, and the sky is looking a bit darker today, with that ash cloud continuing to spread particles right across the eastern and the southern tip of La Palma.
Now, not all the gas that comes out of a volcano like that is harmful, so scientists will test it. And if it is harmful, they will then have people evacuate. If it doesn't have harmful gases in it, sometimes the people can stay. Maisie.
When we're at the blue lava, does it burn you?
So it would be sulfur that would be on fire. So yes, it would burn. That's what would cause that. Remember, it's not lava. It's just sulfur in whatever it is that's burning. Yeah, yeah. All right, so this picture right here, where all the pink is, that shows the earthquakes over the last 100 years. Over the last 100 years, there have been 200,000 earthquakes shown. This one shows recent earthquakes. This one here shows where the plate boundaries are. This shows the direction the plates are moving. And this one shows where tsunamis started. This is tsunami risk zones. These are areas that are greater damage. Now, if we put them all together, look at how they correspond with the plate boundaries. Pretty interesting. All right, that's it for today, everybody. Thank you all for coming. It was good to see you. You guys asked really good questions. Keep them coming. All right, have a great week.
Bye.
Bye.
Wait, hold on. Wait, what just happened? Because I glitched out and I have no idea what just happened.
I was just saying goodbye.
Okay.
All right, thanks.
Bye. Thank you.